Good morning. Good morning, everyone. So my name's Eljane Lim. I'm a medical oncologist and a lab researcher at the Garvan and St. Vincent's. And together with me is my co-convener, Alex Swarbrick, who runs a lab at the Garvan Institute. And we're very privileged here to be standing in front of you to welcome you on behalf of Garvan and St. Vincent's to the second Australian Translational Breast Cancer Symposia. Now, this is the second symposia of this sort. We had our first last year, and it was really catered towards the scientists and clinicians to bring the two communities together so that we can network, collaborate, and ultimately make a difference towards the patients that we treat. It was such a success last year, and in fact, we had a good turnout from patient advocates and research advocates. And the feedback that we got was that the public would like to be involved. So this year, we've extended the symposia for a second half day, which is today. And we've actually invited our public and our patients. So I'd like to say hello to the patients of mine out there today. Thank you for coming. And we'd like to show our patients and the public some of the research highlights from around the world. We've got a distinguished international visitor speaker this morning, Professor Lisa Carey. And we would also like to highlight some of the research that's happening here on our campus at the Garvan and St. Vincent's. Now, one of the goals this year is to bring together some of the major Australian breast cancer support organizations. And this includes organizations such as the National Breast Cancer Foundation, which is our major funder of breast cancer research in Australia, BCA, McGrath Foundation, the ANZ Breast Cancer Trialist Group, Cancer Victoria, Cancer Council, New South Wales, I'm from Victoria, that's why I say Cancer Council Victoria, Cancer Council New South Wales, Cancer Australia, Cure Cancer. So for all of you who are representing those organizations here, we welcome you today. Now, you might have seen in our adverts that Connie Johnson was meant to speak this morning. Unfortunately, she's in hospital, and she sends you her regards and her love. But in her place, we have another patient who will be telling us her personal journey through cancer. But I'd like to pass you on to my co-convener, Alex, to run us through today's program.
Thank you, Eljane, and welcome everybody. I'm Alex. So today, as Eljane mentioned, this is the second symposium that we've put on of this type. This is the first year where we've had a separate day for the community, and so this is really the first run for us. We're really excited to see how this goes. So today we have a number of presentations. The first is going to be from Tennealle Fankhauser, who's a patient of Eljane's and a really passionate advocate for research on campus. Then we're really lucky to have Professor Lisa Carey here, as Eljane mentioned, and she's really one of the world leaders in this space in medical oncology of breast cancer and she's going to teach us about how she sees the future internationally going forward in the research and treatment of breast cancer. Eljane and I are then going to give you an update on local research and local clinical activities, so tell you a little bit about the hospital and the really exciting work it's doing, and then about the labs and the research we're doing in breast cancer. And finally, we're going to finish up with a panel presentation with a number of these individuals representing different disciplines, and that's going to be an opportunity for you to ask questions of them. I'm sure there's a lot of interest and a lot of questions you have about both research and treatment. And so I ask you, if you, probably most of you received a card when you registered. If you have a question, please fill it in and hand it to one of our volunteers who'll be standing on the side of the auditorium. The only thing we ask is that you ask a generic question about the future of research or current activity in research or treatment, rather than something perhaps more specific to yourself or your family. So I want to finally acknowledge the support of Estee Lauder, who have been really tremendous in funding today. It's the only way we can make something like this happen is when we get really wonderful company like Estee behind us, and so I really want to acknowledge their support, and we'll be hearing from the CEO of Estee Lauder later on. So that's all I wanted to introduce. I'd now like to introduce Tennealle. to come to the stage and tell you about her personal experience.
Thank you, Alex. Well, welcome everyone. I'm very honoured to have been invited to speak in Connie's place today. Her heartfelt story of surviving terminal breast cancer is one of courage and determination, and she's a true inspiration. This morning I'll briefly share a little bit about my journey with breast cancer and why I'm motivated to support medical research, and I'm sure there's a number of people in this room who can relate. So I was diagnosed with breast cancer when I was just 36, which was just over a year ago. One night I just woke up in the middle of the night with a sharp stabbing pain in my breast, and that's when I found the lump. And from that night, my life turned upside down. And within a couple of days, I was diagnosed with an aggressive breast cancer, and the lump was 3.5 centimetres long. But nothing can ever really prepare you for the news that you have cancer. I still can't believe it now. And I was shocked and devastated when I found out. You just don't ever expect it to happen to you, and certainly not at this age when you're in otherwise perfect health. I have no history of cancer in my family, so I never thought cancer would be something to be worried about. Being told I had cancer was the first shock, but the second was being told that by my surgeon that I had to have a mastectomy. It hadn't even occurred to me that that was going to be a possibility. So after my mastectomy, I commenced a grueling 6 months of chemotherapy. In addition, I've been receiving Herceptin, which is the treatment that destroys the HER2 cancer. And after 13 months, my final treatment is next Monday, which I'm very excited about. As I'm sure you know too well, the entire process is just one big emotional roller coaster, not just for you personally, but it affects your family, friends and work colleagues. I'm a very positive person, but there were some very dark moments along the way. Losing a breast and knowing that you have to face 6 months of feeling poorly is challenging both physically and mentally, and some days life didn't feel worth living. Even though chemo has finished, I still get hot flushes, and it will be some time before I return to perfect health. I've lost a lot of confidence and self-esteem during the process. I'm self-conscious of my scarred body, and losing my hair was a big deal for me. When I wake up in the morning, I look like Billy Idol, so it's not good for anyone, really. But on a positive note, it has forced me to reassess my life and make healthy choices and smarter choices for myself. So with my last treatment inside, I'm now in the process of rebuilding my life and regaining my strength and confidence. I eat well, exercise daily, and I feel very positive about a cancer-free future, and I trust that the treatment I received was the best option for me and will have the best outcome. The medical research has come a long way. Patients now have access to anti-nausea medication and effective targeted therapies that deliver more positive outcomes and have less side effects. I can't imagine how awful it would have been back in the day going through chemo without anti-nausea drugs, and the life-saving treatment I'm receiving today wasn't around back then. I've been receiving my treatment at the Kinghorn Cancer Centre under the care of Associate Professor Lim, in addition to accessing the state-of-the-art breast cancer services. Patients at the Kinghorn Cancer Centre also have access to a range of clinical trials. As a cancer patient under the age of 40, I was invited to participate in Garvan's genetic cancer risk in the young study. I agreed to participate because the study aims to understand more about the genetic alterations that cause inherited cancer, and this knowledge may lead to more personalised cancer treatments with better outcomes, improved cancer screening and more fully informed lifestyle decisions. This research will be important for people with cancer and their families. And whilst I don't have a strong history of cancer in my family, it's unlikely I hold the BRCA gene, but there are many other inherited genes that could have predisposed me to breast cancer. So that's why I'm excited to be part of the study, and it'll be very interesting to see Garvan's research progression in this area. Cases of breast cancer are on the rise. For me, it was particularly surprising to see how many young females being diagnosed, and some as young as 18. So medical research is important for us today, as much as it is for the next generation. Being diagnosed on the age of 40 means that I have a much higher risk of the cancer recurrence. That's why it's important to me that medical research continues to make significant advancements in early detection, breakthroughs in understanding breast cancer, and developing better therapies for treating it. So I'd like to say a big thank you to Connie and the Love Your Sister team, to everyone in this room who support breast cancer patients and research through fundraising, and to the impressive researchers at the Garvan Institute who passionately work toward providing hope for a future without breast cancer. I thank you for taking the time to listen to me speak today, and my heart goes out to everyone in this room who has been through a similar experience, either personally or through someone close to them. I trust you'll find this morning's update to be very informative, insightful, and hopeful. And as a final note, I personally urge women to regularly check their breasts for lumps. Please listen to your body. If something doesn't feel right, make sure you get it checked out. So thank you, and please enjoy today.
Our next speaker is Professor Lisa Carey. Lisa is the physician-in-chief at the University of North Carolina. She heads the medical oncology department there. She's a professor of medicine with the university. She's a world leader in breast cancer research, particularly with triple-negative breast cancer, but all types of breast cancer. She heads wonderful consortium of groups in the US called the Alliance, where they pull together their resources and run clinical trials together. We have very much to learn from our colleagues in the US. And she's here today to give us an insight, an international insight into some of the progress on what it means to have personalized treatment in breast cancer. So welcome, Lisa.
Thank you. It's wonderful to see all of you here, and hopefully this will be a little bit informative. I've been asked to talk a little bit about the molecular complexity of breast cancer and try and explain some of the genetic understanding of the disease that's now becoming clearer. So let's start with what's breast cancer. We'll start at the beginning. So, malignant growth or tumor resulting from the division of abnormal cells in the breast. I'm going to cross that off and say from the breast, because wherever it ends up, what's important is where the cancer comes from. So a breast cancer that goes into the liver, for example, is still a breast cancer. And those are important features that we have to keep in mind. So it's breast cancer if it comes from the cells that are in the breast. If it can divide and grow without the normal controls that keep all of our other cells from just dividing in an uncontrolled fashion, if it can invade into other tissues, it's a breast cancer. So, that said, breast cancers are very variable in terms of how aggressive they are from a genetic standpoint, how aggressive they appear under the microscope. The one on the right doesn't look very much like normal breast. We would consider it aggressive or high grade. On the other hand, this one on the left is a little bit more benign looking. It's more closer to what normal breast would look like. So, here's my challenge. Which is the scarier dude up here? Okay, so, Bono, Bernie Madoff, from my country, very famous bad guy, villain, stole lots of money, millions and millions of dollars from lots of people, right? So the truth is, you can't look at a cancer and tell how it's going to behave, because some of the scarier looking ones end up not doing very much, and some of the more benign looking ones end up being very ugly. So how do we understand this better? This is where our partnerships with our scientific colleagues and people like Alex are really key to us understanding things better, and in this case, our friends the fruit flies, who have given us a lot of information about genetics. So here's the primer on genetics, right? So the basics, genes, become RNA, which becomes protein. So there's this sort of cascade of how are cells managed. Now, anywhere in that cascade can go wrong in cancer and does go wrong. So you can have mutations in the genes. You can have what's called epigenetic changes. So the epigenome is normally involved in turning genes on and off, right, separate from mutations. You can have the gene can be perfectly normal, but if the controlling features of whether genes are on or off gets deranged, that's a problem. There's also things that can alter what is made. There's ways of the proteins getting made. The normal function of splicing, of getting different proteins from the same gene, that can get deranged. Proteins are normally modified. They can be modified in an abnormal way, and the degradation processes to get rid of proteins can also get deranged so that they don't go away when they're supposed to. So let's start with mutations. So mutations, so this is the double helix, right? If you have a mutation, you can have an abnormality in what that gene does. Now this can go in a variety of directions. For example, you can have either a mutation or you can have too much if the gene gets turned on. You can have a gene that is abnormal and it doesn't make a protein that's required, like BRCA1, right? That's one of the features of people who have inherited breast cancer is they have mutations in BRCA1 or BRCA2 that are inherited, and then that gene doesn't function correctly. Now, before we get too far into genetics, I'm going to make an important distinction here, right? There's two kinds of breast cancer genetics. There's the genetics of the tumor. Cancers always have abnormal genetics. That's one of the features of being a cancer. That's what makes them a cancer. So the genes in a cancer are always wrong in one way or another. There's also genetics of the person, right? Those are two different things. So the genetics of the person, whatever you inherit, can go along with inherited risk or susceptibility for breast cancer, ovarian cancer, et cetera, et cetera. Those two things are different. So let's talk about the inherited ones, right? So this is what you get from mom and dad. And as said here, it's another thing you can blame on your mother or your father. 5 to 10% of breast cancers, we have a pretty good idea of where they came from. They are because of an inherited abnormality in genes where when they are aberrant, they cause increased susceptibility to getting cancers, particularly breast and ovarian. This is mostly BRCA1 or BRCA2, although there's a whole host of other ones that are also becoming increasingly well described. So why is this important? Well, knowledge is power. So this is Angelina Jolie. This is called the Angelina effect. She has an inherited predisposition to breast cancer, and she had bilateral mastectomies in order to prevent that. I have here, it's usually power. This is Woody Guthrie, a famous folk singer from the 1960s in the U.S. who had Huntington's disease, another inherited thing, but there isn't much we can do about it. So knowledge is only power if you can do something about it. There's been a whole host of research into trying to figure out how to leverage our understanding of BRCA1 and 2, either for prevention, in this case, or to improve treatment. So this is a story that's still being written. As mentioned, the BRCA1 and BRCA2 are the most common inherited kinds of breast cancer, but there's a bunch of other ones. And the fact is, though, that most breast cancers have no mutations. There's even people who have strong family histories who don't have any of the identifiable abnormalities that we can hang our hat on and say, aha, this is why this woman got cancer. This one down here is a newer one. About 30 to 50% of people who hold that mutation, we know get breast cancer, for example. So this is something we're still trying to understand better. But the fact is that you can have a BRCA1 or BRCA2 mutation and not get breast cancer. And 90% of patients, 90 plus, who get breast cancer don't have any inherited or other smoking gun for why they got breast cancer. And the fact is that breast cancer itself is a very complicated disease that's probably multifactorial in terms of where it came from, including why not everybody with BRCA1 mutations gets it. So now let's flip the card over, and we're going to talk about somatic genetic changes. So somatic errors are mutations and other abnormalities that arise in the tumor. The person's genes are fine. The tumor's genes are not. So this is, pretty much all cancers have genetic abnormalities in them, and most of the time the patient's genes are just fine. So here's the thing. All cancers have genetic abnormalities, and there are some that are incredibly characteristic, and they're scattered. There's others that are kind of uncommon, and they're increasingly recognized. And for years, you had people who worked in labs, and they had their lab that worked on P53, common gene that's frequently mutated in all cancers. It's the most frequently mutated gene, period, in cancer, separate from breast. And you had the P53 guys. And then you had other people who were working in RB. And you had somebody else who was working in, ATM, right? These are all these, these acronyms, right? And all these genes, and they weren't really talking to each other because they didn't necessarily know how things interacted. And so, the famous story about the blind men and the elephant, right? And the guy who has the tail think he's dealing with a different animal than the guy who's got the trunk. So this is where the world of what's called omics comes in. So this is the study of a biologic process using a collective approach, right? Instead of looking at one thing here, one thing there, it's an integrated approach at looking at biology. Now, there's a lot of different kinds of omics, right? If it's genomics, then it relates to the genes. If it relates to proteins, it's called proteomics. My personal favorite is this one on the bottom. It came from some people from Hopkins who were looking at proteins in stool and colon cancer risk, and they called it the poonome. So the genome's the best studied so far, but the others are closing in quickly, and now there's integration across the different kinds of omics. So this is the theme, right? Cancers all have mutations that alter the functions of those genes. They all do it. This is normal. Genomics is studying the expression of large numbers of genes simultaneously, okay? So you can identify patterns, right? It's not about any one thing. It's about patterns. So this is where my main scientific collaborator for many, many years is a guy named Chuck Peru, brilliant scientist, although we spend enough time, and he's so interested in clinical care, right? He's the kind of scientist who didn't want to just work in yeast, right? He wanted to work in things that were relevant for people, and so I keep threatening to give him a stethoscope and make him come help me take care of patients because he's that smart. So he actually decided years ago that he wanted to take this emerging omics revolution and bring it right into the patient's tissues and stop looking in test tubes and look in actual human breast cancer samples. So this is what's called a heat map. So each of these dots, the reds and the greens, represents one gene, right? So here's a penny, just to give you an idea of these are unbelievable technological marvels, right? These are microarrays, tiny, tiny, tiny things representing thousands of genes from one breast cancer. So this is what you get, right? This is just a snapshot. This is a piece of what you get, right? This is the kind of data that comes out of gene microarrays, gene expression chips. And your computer helps you make some sense out of this, right? So, you could get something like this, which to us, right, even a very smart scientist would be like, well, I'm not totally sure what I'm looking at. Then the computer starts to put it together. Now, it may not be perfect, but you get a much better sense of what is going on, and you get the patterns, you get the clusters, and you get the color. And you get a feel for why a cancer is behaving in a certain way, what the ripple effect is of certain genetic abnormalities. So that's given us what we call the intrinsic subtypes of breast cancer, which Chuck first reported in 2000. And that's these, right? These are the molecular subtypes of breast cancer based on these patterns. The computer says, okay, these reproducibly segregate into certain biologic groups. So what that means to us now is the old statement of, why did you get breast cancer, or how is the breast cancer doing, almost doesn't make sense, right? Because breast cancer is not one disease. It's a a group of biologically distinct diseases, and we ignore that at our peril, right? We can't move forward if we keep treating it as if it is a monolithic thing, because it simply is not. So what? Now let's move on to what are the implications of our understanding of the molecular underpinnings of breast cancer. So let's start with the basics. What's the point of what we do? When Elgene and I go see patients, what are we trying to accomplish when our surgeons are seeing patients? So cancers, breast cancers fall into two main categories, and I think it's important to highlight this. There's early breast cancer, which is stages 1, 2, and 3. This is most breast cancers are in one of those stages when they're diagnosed, 95%. It's curable, right? And I use that word deliberately. That can be somewhat fraught with some controversy, but to me in the clinic, that is a real end point. I want to cure that cancer, meaning I want my patient to get shot by a jealous wife at age 90, right? Or get hit by a truck on her way to the opera with no evidence of the cancer causing any trouble in her body. So how do we do it? We do it with surgery, we do it with medical therapy, we do it with radiation. The other main category is metastatic or stage 4. That's when the cancer is growing in other organs of the body outside of the breast and the local lymph nodes. That's not at the moment considered curable. It is considered controllable, and in truth, many of the advances in medical therapy, among the best things that we've done is turn certainly a large segment of the population of metastatic breast cancer patients into patients who are living with a chronic disease. So the goals there are control the cancer and maintain quality of life, and those are two equally held goals. One of our key things, though, is let's try and keep this from happening. This happens about 20% of patients become metastatic. So how do we do this? So if the cancer has hormone receptors on it, in those what we call the luminal subtypes are hormonally driven, and we can use endocrine therapy, and we now have 4 or 5 options for endocrine therapy or anti-estrogens. We also have better tests to identify whether the cancer is truly driven by estrogen receptor biology, and also what kind of biology might be best leveraged to treat that. Does it have too much HER2? It sounds like Tennille has this kind of cancer, which is about 1 in 5 breast cancers have an excess of HER2 because the gene, there's too much of that gene, and it's behaving in an uncontrolled fashion. And that used to be the worst kind. It's now actually one of our better prognosis ones because we have really effective anti-HER2 drugs that you can add to chemotherapy or endocrine therapy. There are 4 of these drugs that are now FDA approved in the US. Now, the truth is we're now over-treating HER2-positive breast cancer because we give like 5 drugs to these patients, and they make your hair fall out, and they can make people feel bad, and it takes a year. So which is great if that's what that cancer needs. But among our challenges, we know that many of these patients don't need that much aggressive therapy, but we're not that good at figuring out who they are yet. So I'll talk about that in a second. And then chemo, I'm not going to diss chemo, right? We talk about chemotherapy as one of the goals is to get rid of chemotherapy, and that's a totally valid goal. But the thing we have to remember is as dumb as chemotherapy is, right? We talk about smart drugs and dumb drugs. It's actually smarter than we give it credit for. It's very effective, and it's more effective than ever now. So let me talk about something that we have done in North Carolina that I think has transformed to some degree how we think about breast cancer and the kind of thing you can do when you have epidemiologists, scientists, and clinical people working together. So the Carolina Breast Cancer Study is a very famous series of studies. It started long before I ever got there. The first phases ran in the early 90s up to 2001-ish in the eastern part of North Carolina. Focus on young women with breast cancer and black women with breast cancer because the other studies had a lot of older white women. And so this was clearly a group. It didn't exclude the other groups, but they handled the design of the CBCS so that there were as many young and black women as there were older white women. That was deliberate. And it was really focused on risk. Why do women get breast cancer? In fact, one of the earliest studies looking at the implication of BRCA1 in a normal standard population came from this study. phase 3, which finished up a couple of years ago, took it one step further. It's another 3,000 women from 44 counties in North Carolina, and it actually, for the first time, comprehensively collected treatment information and outcome. So it's not just who got it, but now it's what happened to them and what kind of treatments they get and what worked. So a couple things that we've learned. So remember I said it doesn't make sense to say somebody, like breast cancer as if it's one thing. Well, it also then doesn't make sense to say what causes breast cancer if breast cancer is a bunch of things. And the truth is that it's increasingly clear that there are different risk factors for different kinds of breast cancer. So this means we have to sort of throw out our knowledge of risk and kind of revisit all of that. And this is one example. So for example, if you just look at the most common hormone receptor positive HER2 negative breast cancers, about 70–80% of breast cancers, versus what we call the basal-like subset, which makes up the majority of triple negative breast cancers, the most aggressive kind. And here's a sort of list of what are considered traditional either risk or protective factors. And the thing I want to highlight here is, well, having early menstrual periods has a little bit of an effect on hormone receptor positive HER2 negative. Is really bad for getting basal-like breast cancer. Having lots of children was traditionally considered to be protective, which it is for this kind, but not this kind. Similarly, having your children young, which is also considered protective. This is the kind of thing that people like me who started having our kids, after medical school, were sort of feeling bad about. But in truth, it's bad for this kind, et cetera, et cetera. On the other hand, these are things that we can do something about. Breastfeeding has not that much effect in this kind of breast cancer, but in this really ugly kind of breast cancer, it's a very powerful protective effect seems to be there. Same with obesity. Much more important to control obesity to prevent this kind. If this is so, these are very strong prevention approaches that can be applied strategically, and so we need to do more of this kind of work. So, the other thing that came out of the Carolina breast cancer study, and this was the first two versions of it, and then moving on to the third version, is we learned that young women and black women are more likely to get that basal-like kind, that triple negative kind of breast cancer, significantly so. I'm not going to show this, but from the Carolina Breast Cancer 3, we actually did much more sophisticated molecular evaluations, and it's actually even worse than we thought it was once you get more sophisticated from a biological standpoint. So there really is a reason that young women who get breast cancer, it tends to act more ugly than an older woman. And in the U.S., certainly women of African ancestry. And this has actually been borne out in actual African data sets also, seems to get a different kind. So is this why young women and black women, that's independently confers a worse prognosis? So that's what we thought. We thought, aha, this is the reason for what we call racial disparities in outcome and age disparities in survival. So actually, interestingly enough, while it is true that it contributes, because if you are a black woman in the U.S., you are more likely to get triple negative breast cancer, particularly if you are young and black. If you're going to get breast cancer, then the likelihood is higher of getting this aggressive kind. So we thought, well, that's part of the story. But if that was the whole story, then if you just looked within the types, then you would see an equalization of outcome. That's not what we saw. So here's that triple negative kind. Whites and blacks, again, this is a North Carolina population. You can see, the whites are doing maybe a little bit, but it's not statistically significant. If it's a bad kind of breast cancer, it's a bad kind of breast cancer for everybody. On the other hand, this is the good prognosis kind. This is the best prognosis kind of breast cancer that we have, and this is where most of the racial disparity in outcome is actually coming out. So now, of course, there are social scientists who look at me like I sprouted an extra head, because they said, well, of course, there's actually a name for this. It's called the fundamental cause theory of disparities. Who in the audience has ever heard that? I had never heard that before. But if you are a social scientist, this is a really common phenomenon, that disparities in outcomes actually happen when we get better at treating things, right? Because then you start introducing variables about who has access to the care, who can get to the treatments and things like that. So they were not as surprised at all at this. So we also know from CBCS 3 that there is worse biology within this group, that there are some differences that are emerging that are biologic. Now, why? We don't know yet. But we also can tell there's worse care. We're having more people who cannot get to the doctor to get their treatments, who cannot afford the therapy, who can't for a variety of reasons, or they just get busy and they forget to take their pills, for example. So let me get back to omics and the biology. So here's a 50-year-old woman, otherwise healthy. She's got stage 2 ER-positive, HER2-negative breast cancer. So this is a really common story. This is probably one of the most common stories in my clinic. When I go back on Thursday, I'll probably see a couple of patients with this story. Goal of therapy, again, is cure. So we know we can cure most people with this kind of breast cancer using modern drugs and whatnot. But we treat everybody with a lot of therapy. Can we get smarter? Well, the short answer is we already are getting smarter. This is just one picture of a very famous test that we now can apply on the breast cancer. It's a genetic test to ask whether that breast cancer is likely to do better or worse with just anti-estrogen therapies. So here is actual data that was in that New England Journal paper. These are patients who got only anti-estrogen pills, no chemo, just anti-estrogen pills. If you had a good genetic test, they did really well, right? They really didn't need much. On the other hand, those that had bad genes really weren't doing very well. So more than 30% of them had relapsed, right? And this is relapse in places we can't cure. And they need chemo, right? Because this is not good enough. So the assay helps us decide who we just need to give pills to and who we actually need to give chemotherapy to for this particular kind of breast cancer. So the intrinsic subtype I showed you about, the luminal, basal, blah, 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 right? So that's actually been turned into an assay also that also works in identifying prognosis, good genes, bad genes. And so that's a test. And the truth is, there's about 4 of them, actually there's 5 now, that are commercially available that help us with decision making explicitly to answer 2 questions. Who needs chemo? And how long do you need to give the anti-estrogen pills, right? If you can give it for 5 years, that's one thing. If you got to give it for 10 years, these are not, while they're not chemo-esque in terms of side effects, they do have side effects, and many people don't want to take a pill unless they're going to benefit from it. So these tests actually help us with this particular kind of breast cancer in decision making. So here's the other thing. No surprises, particularly in the U.S., everything related to healthcare is expensive. So these are really expensive tests, but the test is less expensive than chemo. And certainly on a personal basis, the patients are perfectly happy to, if they have to pay for it, but insurance usually covers it. So that sounds great. Genetic tests sound wonderful. Now those are genetic tests. All 5 of those ones had to go through very rigorous testing themselves. Several are FDA approved. There's a whole process you have to go through in order to show that you actually help make decisions. So this is an actual patient. This is a real live patient. Alex, this is the one I told you about. 45-year-old woman. She had locally recurrent triple-negative breast cancer. It's kind of wrapping around the side of her chest. So before, I did not do this. She came to me she went to an overseas company, and she'd had all this molecular testing done on her tumor. She had what's called next-generation sequencing, where you do sort of deep genetic analysis, what Steve Jobs had done to his pancreatic cancer. Tumor vaccine preparation, where you take the tumor and you try and see if you can create a vaccine so that your immune system will fight the cancer. She'd had her circulating tumor cells taken and evaluated. The recommendation from this company was that she should get mitomycin C, which is not a normal drug to give, et cetera, and that you should not give 2 of our best drugs in breast cancer based on these tests. She had mutational analysis that finds a whole bunch of abnormalities, and my favorite was that she had gone to a company that was making a little mouse avatar of her cancer. So they were making a mouse that would develop her cancer, and then they were going to test the drugs on the mouse to decide what drugs I should give her. So, is this a good idea or not? In case you can't tell my level of skepticism about this sort of thing. But I'm not making it up. There's a reality for this thing. So there are actually the president of our National Professional Society is famous for saying a bad test is as dangerous as a bad drug. And he's right, because you can make some serious mistakes based on something that may or may not be valid. So when you do what's called a biomarker, you have to know that it's not something that somebody's doing in their garage, right? It's actually a real test. It's reproducible. If you do it over and over again, you get the same answer. It's accurate. It actually differentiates cancers in a meaningful way. And here's the key part. You better show that using that test helps you treat the patient better, right? Otherwise, what's the point? So here's her list of things. This is actually what I did with her. I'm like, okay, let's make a list of all the stuff you've had done. Because, of course, she came to me saying, I had all these tests done. They're telling me different things. I don't know what to do. Now what? Because I've got 5 different answers, and which is the right one? And I said, basically none of them. And because none of them have gone through any of this. So, I think they're okay for clinical trials, but not for routine use. So just be skeptical. Okay, here's your quiz. So this is a real thing. U.S. Navy study found that the likelihood of death from falling overboard is higher if the sailor's wearing a life jacket. Who thinks that's true? Who thinks it's crazy? Okay, so it's true. Otherwise, this would be a really boring quiz. So why is it true? So those of you who raised your hands, why is it true? You're getting there. Why? No, you're getting close, though. Not quite, not quite. The reason is that the Navy makes them wear life jackets when the weather gets bad. Right? This is the impact of an unmeasured variable, right? Which is famous in our world. If you start thinking one thing is what we call causal, meaning this thing causes that thing, and there's something else in the middle you don't know about, you're going to make mistakes. So this is the story of biology and medicine, right? There's a lot of things we don't know about that are interfering with relationships. So this is true that the different kinds of breast cancer behave differently with standard therapy, and let's just use chemotherapy as an example. So the subtypes of breast cancer that are the most sensitive to chemotherapy have the worst prognosis. That is an absolutely true statement. It's not because they're sensitive to chemotherapy, it's because there's something else that you're not measuring, namely the other biology of the cancer. So let's talk about how we try and understand and peel away the things we don't know so that we can understand these things better. So this is where the patient-researcher partnership is incredibly important. I'm using an example of a study because it's one of my more recent studies that I was directly involved in and developed and kind of designed. So in this one, we wanted to test, this is a common thing, these are all anti-HER2 drugs, and there was emerging evidence that 2 anti-HER2 drugs is better than 1 anti-HER2 drug, right? Which is true, it's also a lot more expensive. So we said maybe so, but let's figure out why and in whom. So we asked women to be in this study, but they had to let us do biopsies of their cancer. 100%. It was mandatory. You could not be in this study if you wouldn't allow us to do biopsies. So, and that's this study. It came out a year or so ago. And the other thing I would want to point out, which is really important, is that the clinical trial, the NIH paid for. The research biopsies, the NIH is not that interested in paying for research biopsies. They're expensive, and it's not going to pay for the science, right? Sort of does, but not completely. That came from philanthropy, and actually it came from Breast Cancer Research Foundation, which is the Lauder Company's foundation. So they paid, so Estee Lauder paid for us to do this biology and clinical trial. So what did we find? We found that, like other people, 2 drugs was better than 1. And if you use a better drug, it's about 60% better than using a worse drug. That was good. But by looking at the different subtypes of breast cancer within what we thought was the monolith of HER2 positive breast cancer, we found that one of the subtypes, I mean, it didn't matter. I mean, this is like 300-fold difference just by subtype, regardless of what drugs you gave. So the drugs were like a drop in the bucket compared to just what kind of breast cancer it was. and whether there were active immune cells in the tumor, right, helping to fight the cancer, was also as important as whether the drug was the good one or the bad one. These are really important things to know about. So treatment matters, but to be honest, I would argue that usually treatment matters less than biology and host factors, the patient factors. Another story about this, so in this basal bad breast cancer subtype, makes up the majority of triple negative breast cancer. One of the key genes in it that's turned on is called EGFR or HER1. We have drugs that inhibit HER1, and there are actually, these are approved drugs that we use in head and neck cancers and lung cancers and things like that. And so we and others wanted to do a trial to say, well, maybe this will help this kind of breast cancer. So we did the trial, and again, you tell my theme, we asked women to let us biopsy their metastatic disease before and after therapy to try and understand why the cancer might or might not respond to the drugs, right? I didn't want to just know, does it respond yes or no? Why? You have to answer why. So what did we find? We found that less than 1 in 3, the drugs worked. Okay? So now you get to the why. So sometimes that HER1, that EGFR, it actually wasn't there. It should have been there, but it wasn't. Sometimes it was there, but it wasn't working. It wasn't doing anything. So you can, inhibit it till the cows come home, but if it's not doing anything already, it sort of doesn't matter. So then there were some where you're like, oh, it's going to work in this cancer, and it didn't, and the tumor had alternate ways of getting around the inhibition that we did. And we could see all of these. So in truth, you got to understand each cancer better in order to get personalized medicine, and this is how you get there. So this actually is something we took it one step further. This is a different kind of inhibition in the same kind of cancer, which was based on some laboratory models that said if you inhibit something called MEK, another gene, it looks important in triple negative breast cancer, that if you inhibit it, the cancer, the back door, at least in the laboratory, in the test tube models, the way the cancer evaded the drug was sort of characteristic. It kept going around. You lock the front door and it goes to the same back door over and over, at least in the test tube models. So we did what's called a window of opportunity study where we gave this drug to women and did a biopsy before and after and said, well, does that happen in people? Does it use that same back door? And the fact is, it doesn't, right? That was the disappointing part, was that it didn't. It used like the side door, it used the back door in some, it used, climbed in through the window in others, right? So there was a lot of heterogeneity in how the cancer learned to evade the drug. The good news, and this is coming out in Cancer Discovery soon, the good news is that the way in which the cancer opened up the doors and the windows itself might be targetable. It's one of those epigenetically, right, mediated things. So if you can shut that down, it may not matter whether it's trying to come in the side door, the back door, or the window. So that's the next set of studies. So what does it mean? Targeting using one drug oftentimes doesn't work. You can try combinations, but then you have to figure out, like, blocking the window, blocking the door. You got to figure out which ones, and now you're adding lots and lots of toxicity in drugs. But, and you get the whack-a-mole problem where you sort of block one thing and another one comes up. But I think we have some new strategies to get around that. So then last little bit, immunotherapy. So this is all the rage, and it's emerging as important. It's clearly important in melanoma. It's clearly important in lung cancer. Breast cancer, there's a hint that immune-based therapies might also have a role to play. This is also a story being written right now. But let me just give you a quick, the primer on immunotherapy. So here's the question. Why doesn't your immune system fight the cancer, right? If you get an infection, your immune system kicks in and says, that doesn't belong here, get it out, right? Well, there's two reasons. One is cancer's not really a foreign thing. It's not like measles, right? It actually comes from your body. So there are elements of the cancer that look like the rest of the body. The other thing is cancers are smart, right? There's another one of my colleagues was famous for once in a public forum saying, one dumb tumor is smarter than 10 smart oncologists. He got in a lot of trouble for that. But the truth is that cancers do evade the things we try to do, right? They mutate, they do all sorts of things. One of the things they do is they throw essentially an invisibility cloak over themselves. This is actually a very, increasingly well-described thing. And there are drugs that peel that invisibility cloak back so that the immune system can actually see the cancer, right? That's what a lot of these drugs do. So I think there's real promise there, but it's a work in progress. So here's this is the hallmarks of cancer. And as you can see, there's lots of different features of cancer, all of which people are developing drugs. And so I would argue that the future of cancer therapy, particularly breast cancer, is likely to be multi-pronged. It's going to be a variety of approaches kind of work together in an integrated fashion in order to really improve cure rates and improve control. So this is my last thing. This is the Eagle, which is a pub in Cambridge. I had the pleasure of being a visiting professor at Cambridge, and I went to visit this. This is where the DNA helix, Watson and Crick, the DNA helix, they actually publicly talked about this for the first time in a pub, which I have to say I really liked that. And what reminded me as I was there is, there's pubs and there's silos. And much of cancer research has come from really smart people working in their silo on what they do. And I think that's good, but I don't think it's great. I think that the biggest transformations in how we take care of our patients and our understanding has come from people hanging out in pubs, talking to each other. And so the key thing as you're trying to build something, and this is certainly a strongly held philosophy that I think many of us have in the U.S., is we have to be spending time in pubs, right? With scientists, I mean that in all sorts of ways. Scientists and clinicians and epidemiologists and population social scientists need to all be spending time together. Otherwise, it's really hard to get anything done. I think you guys have pubs here, I hear. The Green Park, in fact. So I think recommend that all of your scientists go hang out in the Green Park as much as possible. So, modern breast cancer care, this is Sir William Osler. I was at Johns Hopkins in Baltimore for 11 years. Very famous guy, lived in a silo, did a lot of great things, but that's not how we transform care. This is how we do it. And it's integrative, it's across disciplines, it involves lots of people helping, and it involves our patients as key partners in this whole process. Thank you. Sure.
Thank you, Lisa. Are we on here? There we go. Thank you, Lisa. That was a phenomenal journey through the fundamentals of cancer and right through to modern day clinical care and research. So we've got a bit of time for questions. Before we ask some questions of Lisa, I encourage you, if you have any questions for the panel, that you have written on a card. So these are broad questions about breast cancer risk or about your lifestyle or treatment in general. I encourage you to hand them up to Lauren or myself. But if you have a question more specifically for Lisa on her talk, please put your hand up now and we'll happily bring you the microphone. Elgin, there's one there.
Thanks. Does the invisibility cloak covering the cancer cells have proteins that you can target to kill the cancer cell?
Yes. So the invisibility cloak involves certain proteins. And there's a whole class of drugs that have been developed and are being developed that do exactly that. And they essentially interfere with the cancer being able to hide. They're called immune checkpoint inhibitors, for want of a better word. It's not a very sexy name. I'll have to come up with something better.
This might not be because it's more in Australia. What I wanted to know, if you are a BRCA2 gene carrier, if your child is a carrier at the time of possibly wanting a family, I read that in London they take the BRCA2 gene out of the egg and then reimplant it so that you stop the line. Do we do that in Australia?
I don't know.
I'm going to pass the microphone over to Professor Alan Spiegelman. He's the director of the Cancer Genetics Service here, so he's well placed to answer that question.
The short answer is yes. The longer answer is up until very recently, it was a very expensive procedure, only available in the private sector. And I'm pleased to inform you that later this year, the Royal Hospital for Women will be reopening, as it turns out, a public IVF service that will enable this to continue.
Thank you, Lisa. That was a fantastic talk. I'm just interested in whether you think personal genomics holds much hope for women with metastatic breast cancer, given that they have tumours in multiple areas, and given the tumours then mutate and can change. I mean, there's the issues with testing those tumours. Do you think personalised medicine will actually help them?
Yes, but I actually gave a talk yesterday, another skeptical talk. The way we're doing it right now is kind of like looking under the lamppost. And I think when you look under the lamppost, they're using assays that look for what are considered to be driver genes, right? So commonly mutated genes in breast cancer. The likelihood that you're going to find something that will be transformative in treatment for an individual patient is actually quite low, right? However, right, so the trick is you got to make the light go further and go further into the darkness. I think it is likely that personalized medicine in the future is not going to be, what's right now focused on is mutations and structural abnormalities in DNA. That's pretty much what's tested for. That's what the commercial assays do. In the future, I think it's going to be much more about RNA, proteins, and more integrated thing. And so the targetability sort of landscape is going to be totally different than it is right now. So I think we're in the beginning. I'm a little pessimistic that the kind of approaches that have helped at least a subset of lung cancer patients, for example, I don't think there's a lot of promise we're going to see much of that in breast cancer. On the other hand, I think there's clearly targetability, sort of big swaths of targetable biology if we figure out how to do the precision medicine assays more comprehensively. So I would say not right now, but yes in the future, and that'll be the next generation of studies will be looking more broadly. The reason they don't do it now is it's hard, right? It's easy to do sequencing for P53 mutations. Right? That's just not hard to do. There's lots of companies that do it, and they do it very well. It doesn't hold a lot of promise in terms of real treatment effects. So we're going to have to figure out how to do the hard things in order to make a transformative change.
And can you give a timeline on that?
Few days.
Can you just tell me, it's a simplistic question really, what lifestyle changes have the biggest impact on breast cancer?
Lifestyle changes for prevention of breast cancer or once you've had breast cancer?
Yeah,
so this is a complicated answer here. The first is that in general, healthy lifestyles are associated with better outcomes, right? Low-fat diets, exercise, not smoking, things like that. However, is that it's not entirely clear that the lifestyle itself is doing that, or just that people who do those things also take better care of themselves, right? There are actually some studies going on right now in the U.S., and I think here, right, you mentioned one yesterday, where they're looking at, a more direct effect of lifestyle changes. Here's the more complicated thing, and the reason when patients, read on the internet and they say, well, I've got to do a macrobiotic diet, or I'm going to do this, that, or the other. I always say to them, that's fine if it makes you feel better. But don't do it because, someone told you have to do that. to keep your cancer from coming back. And the reason, avoiding sugar, that's the big one. They all say you got to avoid sugar. I don't know, because PET scans, have sugar in them, but I think, there's no real data that avoiding sugar is going to matter for whether your cancer comes back. Your cancer, your liver makes sugar, right? It doesn't need what you eat, and cancers grow just fine whether you eat or not, right? I've had lots of patients where the cancer is growing even when they're not, they're withering away and not eating at all. The cancer still grows. The reason I'm a little bit forceful in saying don't do it because it's going to change the cancer outcome, because we don't know if it will, is because I think it's mean, right? Patients get on the internet and they read this stuff, and they're well-meaning people say, oh my God, you're having sugar? You're having a piece of birthday cake with your kid. Don't you know that means your cancer's going to come back, or you're taking a real risk by doing that? I think that's mean, because A, I don't know if it's true or not, right? In fact, I suspect it's not, and B, if the cancer does come back, somehow she's to blame. Like, that's just wrong. So I'm, it sounds good. Like, oh, let's do all these things that can help, right? And I think people are very well-meaning, but I think the flip side, there's a dark undercurrent of somehow making it the patient's own fault when there's no data to support that. Does that make sense? Not that we know of. Like I said, people, fortunately, the data suggests that the groups of patients who do the best are those who also have a healthy lifestyle. I just don't know if that's called like the healthy patient effect. I don't know if it's because of the lifestyle or just because patients who take care of themselves take care of themselves.
Okay, I think we better move on to the next session. There will be plenty more time to ask questions when we have the panel up on stage, including Professor Carey. So please join me in thanking her for a brilliant presentation. Okay, so next up, Elgene Lim is going to tell you a little bit about the clinical services and some of the research happening on campus, and then I'll follow up after Elgene with a bit more details on the laboratory-based research we're doing.
Rob, can we have the slides, please? Thanks. Next slide. Okay. Cool. All right. So this is an overview of the breast cancer services and research program at St. Vincent's and the Garvan. As Lisa say, we're not a silo, we're not a pub either, but we certainly come together and work together, the clinicians and scientists here at the Garvan. So I think what's key, how do you get the green light? Okay. What's key in the middle is that what we do is patient-centered. And I think that's what drives our research endeavors, what drives our clinical services. So at the very top is our clinical service, and I'll talk more about that in a little while. A key component of that is the fact that we run clinical trials here. So that gives us access to drugs that you can't get off the PBS, off the government. It gives us access to innovative drugs through participation in clinical trials. We have a big biobanking effort here at the Garvan and St. Vincent's, where we invite our patients to donate their tissue for research. And we've got a big discovery pipeline, so geniuses like our scientists like Alex and the many other labs here at the Garvan churn out amazing discoveries in the lab that we need then to answer the question, does this work in patients? We've got external collaborations, and I've just listed a few here, but a lot of them are within Australia, a lot of them are international. And we've got a community service and a research and patient advocacy program, and a number of you seated amongst us are actually our patient advocates, our research advocates. You're key to bring the important news to the broader public about the importance of breast cancer research. So this is just an overview, a snapshot of our breast cancer services. The very front, the breast surgeons. Many of you, particularly if you've been treated here before, recognize some of these faces. So our breast cancer surgeons right here. Found the green one. Fantastic. We've got our plastic surgeons, radiologists, Alan Spiegelman, who runs our cancer genetics service, our pathologists who looks at the tumors under the microscope, and advises us how best we should classify these tumors. Our radiation oncologists who give radiotherapy, and then the medical oncologist, Rachel Gear, and myself. So we do offer a comprehensive clinical service. Unbeknownst to you, we actually discuss together. We come together in a huddle once a week to discuss every new case that comes through our door and make a collective decision on what's best for the patient collectively. Now, this is our research team. So that was just our clinical team. This is our research team at the Garvan. So we really study everything from normal breast development right up to primary breast cancer, right up to metastatic breast cancer when it's spread elsewhere and when it's developed treatment resistance. And a lot of our questions are aimed at answering these questions, these important biological questions of how cancers develop and how we actually treat cancers and how we overcome treatment resistance. So Chris Ormandy, David Ortega, Sam Oakes run the Cancer Biology, Tumor Development and Cell Survival Lab. Alex runs the Tumor Progression Lab with Sandra O'Toole, who's also a pathologist. We've got epigenetic research, Sue Clark, Claire, and Fatima. And I run the Hormone Receptor Lab and clinical trials side of things, and we've got Liz Keldon and Christine Schaefer running other labs as well in breast cancer. So this is a snapshot of the number of researchers here we have at the Garvan trying to work together as well as individually in our areas of expertise trying to decipher the breast cancer riddle. This is just a snapshot of our government-funded grants and fellowships. So we've got quite a number of NHMRC grants collectively. Cancer Council New South Wales, NBCF is a major sponsor of our projects. We've also got a few fellowships here. These are the organizations who actually invest money into people such as myself to allow me to spend time doing research as opposed to seeing patients 5 days a week and therefore not advancing the research agenda. So I'm an NBCF practitioner fellow, but we've got quite a number of others here, and from Cancer Council, Cancer Australia, NHMRC, and then PhD scholarships as well for the next generation of researchers coming through. And these are our funding agencies. And you might think, oh, that looks like a pretty healthy number. But the reality is that our government, I mean, when you look at NHMRC, the success rates of project grants that the government funds each year is about 12 to 13%. And what that really means is that 7 out of 8 projects that get put forward to our government unfortunately does not get funded. So we're actually doing pretty miserably as a country in terms of research investment. And it's important, therefore, that organizations like NBCF and others step into the gap and really help our country invest important money back into research. So what really drives us as a group of scientists and clinicians are our patients. That's Connie Johnson and Sam Johnson, her brother, who through their enormous effort raised a significant amount of money through cycling across the country. And just want to sort of put it out there, they're also raising some, turn TV off. They've just got a new initiative where Australia's decommissioned their 5-cent pieces, and Sam and Connie have asked us as Garvan and all of you to partner with them. All those 5-cent pieces that are being decommissioned, don't throw them away, don't give them in, donate them to breast cancer research. So if you could just pass the word around, that would be a great way to raise money for breast cancer research. You know, we're the guys down here, we're the Elmos with ideas, and we would, you know, we need important, we're inspired by people, but we need important partners to make this happen. So our funders, such as NBCF, the Australian government, Love Your Sister, and the community. So this is, you know, this is one community event. This Three Sisters here, the Rizzos, they run a dinner each year to raise money for breast cancer research. Marvelous, marvelous community effort. And you know, our research would not be possible without community organizations such as that and individuals. So I think one of the things that set us apart as a cancer center is the fact that we also see our patients as key partners in our research endeavor. So we have a project running here called Project Share, and literally it's about sharing our patients' tumor specimens. So we ask our patients, be it patients undergoing a mastectomy to cut out normal breasts, because we do study normal tissue, non-malignant tissue. We study DCIS, ductal carcinoma in situ, patients who are having surgery to their breast or their lymph nodes. We ask them, would you mind giving us a piece of that tissue for research? And then more recently, we've also started to ask our patients with metastatic cancer, do you mind, would you partner with us and let us put a needle into that liver lesion or that lung lesion so that we can answer that why that Lisa was talking about. Why does this happen? And a lot of our patients have actually said, yes, please take a part of me and send it to the lab. And we would not be able to do the sort of research that we do here at the Garvan if not for our patients. So we have a number of innovative trials. The clinical trials that I spoke about earlier on, a number of them are sponsored by pharmaceutical companies, and that's an important partnership because the pharmaceutical companies have often developed the next generation of drugs, and the only way for us to get our hands on that is to do a clinical trial. So I'm like constantly getting our pharmaceutical companies to let us run their trials here in Australia at St. Vincent's. But above and beyond that, we also run a number of trials that originates in Australia, originates in ideas that come from researchers in Australia. So this is one example, and it's what we call a window study. Lisa alluded to that before, where the patients often have a sort of 2 to 3 week wait between diagnosis and surgery. In that time, we can actually ask a very important biological question. And this work, so this particular trial, after the patient's diagnosed with cancer, we randomized them to a number of different treatments, including one called progesterone. And then we then take their tissue at surgery, and that then gives us a pre-treatment and a post-treatment sample within the same patient that we can actually compare the two. So this trial actually stems from seminal work that was authored by Australians. So these are Australian authors who discovered this work, the importance of progesterone. One of them sitting right here, Wayne Tilley. Another one's Jason Carroll. They're both Australians. And they made this seminal discovery. And we have the privilege here at the Garvan St. Vincent's to partner with such eminent researchers to really ask that question instead of in a mouse now, in the patient. So that is one example of innovative research done here at the Garvan. And then Lisa was alluding to this exercise. So I have a PhD student who's got NHMRC scholarship who's about to started this month. And she's going to work on mouse models and put them through the paces and in patients in parallel. So this is the sort of research that we do here at the Garvan, where we look at the lab and in parallel with patient research as well. And then finally, there are two other research initiatives that Tanil referred to. This is based on the genomics technology that we have here. So the Garvan has the largest genomics sequencing facility in the Southern Hemisphere. So we've got two studies. Tanil's on one of them. So this is a study for young patients under 40 with cancer. And we want to ask, what is it in their genes that predisposes them to cancer? We hope to accrue 1,000 patients for the study. So that's a cancer risk study. And then we also have, in parallel with that, a study for patients with metastatic cancers, not just breast, but any cancer, particularly the rare cancers. And what we do is we sequence the tumor to try to understand what drives the biology within that tumor and what novel drugs could we potentially use to treat that patient. So that's called the MOST study, and that's also being run here at the Garvan. So there's a whole bunch of innovative research going on here at the Garvan and St. Vincent's in the patient setting as well as the lab. I'll pass on now to Alex, who will speak about some of our lab research here at the Garvan.
Okay, does everyone just need a minute to have a breath, maybe stretch? It's been a lot of information, hasn't it? Let's just kind of shake it out a little. It's difficult to follow these guys, but I'll do my best. So what I want to do today is tell you a little more detail about the research that's going on locally and show you how that fits into the kind of larger international endeavor that we're around. And I think it's probably worth reflecting on, you know, why are we here? Why are we doing this? Sometimes it's almost easy to get the impression, though I'm sure this audience doesn't have that impression, but in the wider population, that breast cancer is kind of fixed, you know? We're putting too much money into it. It's not really a problem anymore. We've got these new drugs. But we know that, you know, today alone in Australia, 40 women will be diagnosed with breast cancer. Now, 30 years ago, about a quarter of them wouldn't make it to 5 years following diagnosis. They would die from that disease. Whereas now, 10% or less of those patients will die of their disease. And the reason for this is research. We've got better screening tools and better drugs. Things like Herceptin that we heard about, things like tamoxifen. And the only way we got them is going from basic laboratory research into the kind of clinical research that Elgene told us about, into clinical trials, which provides the overwhelming body of evidence that these drugs are going to help save lives. So the other thing about breast cancer is that it is hugely impactful on our society. Breast cancer is diagnosed in people that are younger than many other types of breast cancer. We heard from Tennille, who was diagnosed, I think, at the age of 36, and this is not uncommon. Breast cancer diagnoses are in people's 30s, 40s, 50s, 60s. They're our colleagues, they're mothers, they're sisters, and they are very much the fabric of society. And so when people in the prime of their lives are struck down like that, it has a huge impact. And in fact, if you look at the number of healthy life years taken by cancer in our community, breast cancer is at the top of that list. So in Australia last year, breast cancer stole 62,000 healthy years of life from our society. So I don't think that's a problem that's fixed yet. So let me move on now and go on to show you some of the stuff we're doing to try to get at the remaining problems that are now left for us, the challenges we're trying to face. Now, I think Lisa really introduced to you very nicely the medical management of breast cancer, and so I'll simply just say that if your breast cancer is still in your breast, it's incredibly well managed now through things like surgery, for example. The problem that we face, and this is what I want to talk about now, is metastasis. So once your cancer decides to pick up and leave, spread through the blood, and go to other organs. And this is a slide just showing you some of the typical organs different diseases spread to, and in green here is breast cancer. So breast cancer, when it does metastasize in those 20% of patients who are unfortunate enough to have this, it goes to places like to the liver, to the brain, and to the bone. And this is when it becomes more of a problem. We can't cure it with surgery. You look at this scan, this is the outline of a woman with breast cancer, metastatic breast cancer, and it's obvious to me and to you too, I think, that no surgeon can now cure this woman of breast cancer. And so what we need are drugs that we can put systemically into the patient that will travel through their blood and try to kill each of these different tumors now. It's not one we're fighting, it's 5, 10, 20. So the approach we need to take is personalised medicine, and in fact, breast cancer is one of the greatest examples of personalised medicine. Lisa has already told you about this to great extent, but just to kind of summarise in a simple way, the idea of personalised medicine is that just like you're all different, so are the cancers of cancer patients, they are all different. And so the objective of our research really is to understand what the right drug is for the right patient. And there, if you take a kind of a mixed population here of breast cancer patients, this group of patients here, they will gain benefit from the drug that you choose, but it will be toxic to them. So perhaps we want to try to think of ways to manage that toxicity or to shorten the duration of treatment. For these patients, the drug's going to be toxic and they're going to gain no benefit whatsoever. And so obviously we don't want to give drug X to these patients if they're only going to suffer from it. What we want to do is to identify these patients where the drug has limited toxicity at least, and they will benefit from it. And so really the kind of cornerstone, and we've already heard about this now, is by building these relationships, this kind of virtuous cycle that goes between the lab, clinicians, their patients, and the community. And I think once we can build this partnership, this is going to let us crack some of these incredibly difficult but incredibly important questions. Now, Elgene talked about some of his recent efforts in working with patients to take excess tissue that is not required for diagnosis and to use that for research. Now, one of the challenges is that you can imagine a tiny fine needle biopsy of a lesion in the lung, for example, doesn't give us much to work with. It also doesn't tell us about the way cancers are different between different organs. And as you saw in that scan, when patients return with metastatic disease, it can often be in multiple sites. And really, because surgeons don't try to cure metastatic disease, we rarely get access to that tissue. So a new program we're setting up at Garvan is known as Monarch. And this is a difficult topic to discuss, but I think it's an incredibly important one. And essentially what we do is we partner with patients who are coming towards the end of their life from their metastatic breast cancer, with their families, with their treating doctors. And in a conversation, we try to work with them to see if they're willing to donate their tissue after death. Lisa runs probably one of the world's most significant programs like this, and from that they are gaining remarkable insights into metastatic disease. What makes it tick? And this is something we want to set up here on campus. So going beyond kind of access to clinical samples, we also need new ways to study cancer in the lab. Now, you probably imagine us studying like petri dishes with cells growing on the plastic, right? And that's gotten us a long way, it really has. But we need to do better than that. We understand more about the sophistications of cancer. And so as part of our goal to find the right treatment for this patient, as an intermediate, we are using mice. Now, this probably sounds crazy to some of you. What does a mouse have to do with human breast cancer? It happens that mice are easy to grow, they're mammals, and we can actually implant human cancer cells into mice, and they grow there and maintain many of the features that they had back in the patient. And what this lets us do now is to run mini clinical trials using these mice. So if we have an idea, I think this test predicts response to this drug, before we need to rush into a human clinical trial, we can now test this in a mouse. We can put the tumor from a patient into these mice, treat them with a number of drugs, and see which one gives us a response. And that gives us greater confidence than when we move back into the clinic, and perhaps helps us refine our question. And so this is something that we're very active in here at the Kinghorn and the Garvan Institute, developing many of these models that capture all the different types of breast cancer. And when we do this, we then share them with our scientific collaborators so they can also use these to accelerate their research progress. So I want to talk now about a couple of research areas that are strengths of our department. The breast cancer research at the Garvan Institute is traditionally one of its strongest research areas. We've made some really incredible developments in this space over the last 2 decades. And I want to summarize some of the things we've been doing very well and are continuing to do, and then some new areas. So the first is hormonal therapy. We heard already about tamoxifen, and many of you will know about tamoxifen. Essentially, we know that estrogen in a woman's circulation, a proportion of these breast cancers, as Lisa said, about 70%, essentially feed off estrogen. It acts as a stimulant. It drives their growth. And so along came this drug tamoxifen that essentially blocks the keyhole into which estrogen locks, and it now stops it from driving the growth of the cancer cell. Now, while we've saved tens of thousands, perhaps hundreds of thousands of lives through the advent of these therapies, the problem is that a proportion of patients still progress under endocrine therapy. And so this is a major challenge for us, is understanding what next, how to treat these patients for whom these drugs no longer are effective. And Elgene actually touched on this idea that research that he and others are doing, our collaborators, we've learned that other sex hormones like progesterone, like testosterone, can play equally important roles in controlling cancer cell biology. and that it's particularly important in these estrogen-driven cancers. And so this is a really exciting area of research, understanding whether now drugs maybe that were even developed to treat prostate cancer might have a role in a proportion of breast cancer patients, for example, or whether progesterone, as we heard from Elgene, might be another line of therapy that we consider for these patients. Chemotherapy resistance is another issue. As Lisa pointed out, chemotherapy is an absolutely important building block for cancer therapy, and it will stay that way for quite some time. It benefits some patients, but as we saw in the beginning, there are many who gain no benefit at all, and some of them get some quite significant side effects from the chemotherapy. And so at Garvan, we have a number of groups who are trying to answer this question: how can we predict up front who's going to benefit from the chemotherapy? Who should we give it to? Who should we not? And then a second question we have is, are there ways that we can increase the impact of chemotherapy? How do cancer cells dodge around chemotherapy? Why doesn't it kill every cancer? And is there a second combination treatment that we can give to kind of close that escape route that Lisa described for you? The second area of biology I thought I'd touch on is a recognition, I guess, that a cancer, just like any organ you look at, is a mixture of cell types. If we think of it as a homogeneous blob of cancer cells, when in fact many cancers, or all cancers, are composed of different cell types. In many cancers, actually, the cancer cells are in the minority, and instead the tumor is filled with other cells. These can be things like fibroblasts. These are the guys that heal wounds in your skin, for example, immune cells, blood vessels, and so on. And there's an incredibly important new understanding of how, almost like an ecosystem, cancer cells interact with these other cells around them. In some cases, these cells promote the tumor and provide a fertile environment. In other cases, these cells are trying to kill the tumor, and we need to help them. And one of these, of course, is immunotherapy. And so Lisa touched on this. Essentially, what happens is cancers are very tricky. They manage to find ways to avoid the immune system. And essentially what happens when an angry immune cell comes sniffing around a cancer cell, it gives it a kind of a, hey, I'm one of yours, you know, the club handshake, essentially. This is not the droid you are looking for, kind of thing. And so essentially this is this kind of handshake, and the immune cell wanders off kind of dazed, and the cancer cell keeps growing. And what we've, this is the royal we, I had no role in this, but many brilliant people have discovered the actual molecular nature of that handshake, and they've designed drugs that essentially break that. Suddenly the immune cells see the cancer cell for what it is, and in a proportion of cases, kill those cancers and kill them very effectively. And you can imagine, if you can make your immune system angry at a cancer, that cancer has no chance. And so we've seen probably some of the most remarkable developments in cancer therapy ever are in this space. It's been led in other cancer types, like metastatic melanoma, for example. This is a patient riddled with disease. Every black blob is a metastatic lesion, and 8 months after treatment, these are actually normal organs that light up on the PET scan. It's basically undetectable. And so in a proportion of patients who were probably previously would have died from their disease very soon, some of them are now literally cured for life, it looks like. So there's great excitement in this space. And so this is an area that's really exciting us as well, this idea of, instead of just targeting the cancer, which is a very important area that's ongoing, can we also target the soil in which that cancer grows? The cells that provide a receptive environment for the cancer cells. Can we wake up the immune system? Ways to try to activate that. I want to show you one more example, and I think what's nice about this is it shows you the value of fundamental research and how that can lead to clinical outcomes. So I work on a gene that is bizarrely called hedgehog, and I'm going to tell you the reason for this. It was actually discovered in fruit flies when they made mutations in fruit flies, a very easy model organism to make genetic changes. And when they did this, one of these flies had these bristles that stood up on end like a hedgehog. This was actually the cornerstone of a discovery that went on to win the Nobel Prize. Some very clever chemists then came along and actually figured out, and biologists figured out, that this gene is actually mutated in some human cancers. They then made a drug, and that drug is now actually approved for treating certain cancer types like BCC, particularly when these are inoperable, when there's so much of them, a surgeon can't cut them out. And so this, from this fundamental discovery in a fly, we now have this clinically approved drug for BCC. Now, my lab discovered that a subset of breast cancers, in fact, these really aggressive basal breast cancers that Lisa introduced, these guys have very high levels of this gene as well. And we've now done experiments in these mouse models that I described to you showing that here's the growth, the size of these tumors if we left them untreated in the mouse. And when we give them combination therapy of a chemotherapy to kill the tree and the anti-hedgehog drug to kill the soil, these tumors can no longer grow in these mice. And in fact, we also almost wipe out their ability to metastasize in these mice. Now, on the basis of this, we went on to initiate a very small phase 1 clinical trial with collaborators in Spain. And I'm very pleased to announce that out of the 12 women treated with this combination, 3 of them received benefit, clinical benefit, and in fact, one of them, their metastatic disease disappeared. And so this is a scan you can see here, these metastatic lesions in the lung of a woman with breast cancer who's already been through treatment with conventional therapies. These now become undetectable. So we're very excited to see whether we can push this further into clinical trials. But I think it shows how unexpected discoveries in the lab can end up actually potentially changing people's lives. So I'm going to finish up there, and one thing I want to say is we often get asked, what can I do by members of the public or by advocates? And I think there are 3 things you can do. The first is, in some areas, faith in science is being challenged at the moment, and I think so something you can do is literally be advocates for us. Talk to your family, to your friends, to your local representatives, and tell them how important science is. The second thing you can do is think about supporting us. As you've seen the benefit of philanthropy, it lets us form that pointy wedge in which we take risks and really push into new areas. And the third thing you can do is if yourself or people you love are being treated for cancer, is to consider joining one of our many clinical studies, which I think helps the broader community advance. So with that, I'll finish up and thank you for your time. Okay, so we're going to have some time now for a Q&A. I'll get some, maybe if we could have, get these chairs set up. And while we wait, I'm just going to introduce you to our panel members, some of whom you've already heard from. So I'll ask Professor Lisa Carey to come to the stage. Tanil will be joining us on the panel as well to kind of represent the patient's experience. We're very lucky to have Lee Hunt, who's a director of Cancer Voices, who is a very active cancer advocacy organization here. Professor Alan Spiegelman is the director of our genetics service here at St. Vincent's. So he is a great person to answer questions about family risk and so on. And Sarah Hosking is the CEO of the National Breast Cancer Foundation. There we go. Yeah. If you have any more questions that you'd like asked, please just wave it in the air. That's it, and we'll collect it for you. Since you've got the mic, you touched on in your presentation some work you're doing to look at the role of exercise in breast cancer. So perhaps you could tell us a little more about what you see as the role of exercise in breast cancer development and treatment.
Yeah, so Lisa alluded to that in her discussion about lifestyle. Typically, when patients ask me that question, what can they do? I tell them to live a healthy lifestyle, and that really includes exercise. There's been some interesting work in the space of melanoma and other tumors that show that exercise actually increases the amount of immune cell infiltration into the tumor. So we're trying to see if that happens in breast cancer in our mouse models as well as in our patients. And in the patients, we've actually got a study proposed whereby patients who are undergoing what we call preoperative chemotherapy, which is chemotherapy before they have their surgery. They have an exercise program, individualized exercise program for them immediately after their chemotherapy. And then we can actually look at the immune cell infiltration in their tumor at the time of surgery.
Maybe on the, I guess on the note of lifestyle influences, Lisa, perhaps you'd be willing to comment. We've been asked by a number of people from the audience about the role of stress in cancer and what your perspective is on that.
I think stress is bad. No, I mean, this is, for all of our patients, there's like a holistic, you want to take care of your patients. I don't want patients to feel stressed. I have to say we have, at the University of North Carolina, we actually have an entire branch of psychiatry that is dedicated to psycho-oncology. It's dedicated to helping patients navigate this journey as successfully as possible, and it's very, very effective. Now, what people want to know is, did I get cancer because I'm in a high-stress job or whatever? And the data that actually connects stress to the development of cancer or the behavior of cancer is actually not very strong. There have been studies that have done this sort of in terms of self-reported stress levels. There's actually been studies where they looked at stress hormones and cancer type and cancer behavior, and there's not a very tight correlation, which isn't to say it isn't important. I mean, and it is also very difficult to study. It is important. It just may not be the reason that someone got cancer. So I think it's an unanswered question at the moment, but it is important to manage it. It just, I don't know that you can say that you can reduce your risk of getting cancer by changing jobs.
Okay, thank you. We've had a lot of questions, Alan, about, I guess, breast cancer risk. I think Angelina Jolie's case raised a lot of awareness in the community about this. So perhaps you'd like to comment on the effect that that's had in your kind of clinical service.
Sure. So clinically, our experience, and that's mirrored across Australia and across the Western world, is that the number of referrals doubled immediately and continues to rise. And that's certainly a tribute to all the publicity that surrounded Angelina Jolie. And although the focus was on breast, in fact, her family history was ovarian cancer. And that's just as important. And I think we're still only scratching the surface, to be honest, and we know that. The other thing I'll say, just in case I don't get the microphone again, is about looking at the audience. I think 10% of the audience here are males, and I don't think we should forget that males are affected as well. Not so significantly in terms of breast cancer risk if they carry a mutation, but very significantly in terms of prostate cancer risk. And what's more, the prostate cancers that males with BRCA mutations sustain are much more aggressive and require earlier intervention. And that is a message we give to all of our male patients, and particularly to carry to our urologists, meaning not just our urologists in the community, because it's not widely known.
So what impact has that had, I guess, on the prevalence of people undertaking testing within their families? Are you seeing a lot of people going to, particularly to outside services, that they're concerned that they may be carrying a risk allele?
Yes, a lot of it, when we looked at our referrals, the majority are patient-driven. That's turning around here with the breast team that we now have, and breast surgeons and the others that Elgene alluded to in medical oncology. But very much when Angelina Jolie hit, it was patient-driven. That continues to be the case. There are some who don't want to have testing, even though there's a mutation in the family, and that's their right. But we do like to at least have the opportunity to explain the pros and cons of the test for them.
Okay, thank you. I'd like to ask you, Lee. So Lee Hunt, second from the right here, is a representative from Cancer Voices, one of the most active advocacy groups in our community. Perhaps you'd like to tell us a little about the role that Cancer Voices plays, both in policy as well as in research funding.
Cancer Voices is an advocacy group, but a major part of Cancer Voices has been developed by a lot of hard people working towards this, of having consumers involved in research. And how it works is that for funding to be granted, a number of funders now are asking for the consumer to be involved. And so what we do is match trained consumers to a research project. I have a list of different consumers in my data bank, and a researcher will make an application and give me an idea of what they're looking for and where the program's heading. And I will then send the contact details of someone who's able to take on the project. But why have a consumer in the project? It's very important because the consumer gives a perspective, not of a patient who's undergoing treatment, particularly in a clinical situation, but of a person who's actually going to look at the wider picture. A researcher might just be working in the lab, no understanding of what the cancer patient's going through. So that's where the consumer can actually make them see an area that they mightn't have thought of. And I know we did a survey last year of our researchers and consumers that have worked on projects over the last 2 years, which was several hundred people. We had about a 6%, no, it was higher than that, about a 70% response rate, which was excellent. And researchers said years ago they never worked with a consumer, but now they will only work with the consumer because they think they looked at areas that might be doable, but not at areas that are really tough. But the consumer made sure they focused on every aspect of the cancer research. So the side effects, who it's going to benefit, much bigger picture than I've had a success with this type of cancer.
So, Lee, one of the things, I guess, driving researchers to incorporate advocates in their research is that many funding agencies actually demand that of us now, so that we have to have a transparency in the way we apply for funding. And a number of agencies like Cancer Council in New South Wales and the MBCF have consumer advocates as part of their assessment process. So
Yes,
would you like to comment on that?
Cancer Council New South Wales, the program's been developed with the Cancer Council, and they have a consumer-led panel that evaluates each research application, and 50% of the marking to get that funding comes from that consumer group. So it's a huge part. There's many research funders are now seeing the advantages of having the consumer involved. And we're not only involved in research projects, we're actually on a range of different committees too, looking at all aspects of cancer treatment. So post-treatment, lifestyle, because the journey never ends. Once you've been diagnosed with cancer, it goes on for the rest of your life.
So while we speak about research funding, it might be good to hear from Sarah Hosking from the NBCF. I know that you guys are kind of looking at the way you fund research and trying to think of new ways to do that. Could you tell us about that?
Yeah, sure. I mean, there's a real passion and drive for research throughout Australia, and I think it's really important to know that we have the best facilities and the best researchers of anywhere in the world. We're not in any way second tier. We're absolutely front-running along with our international colleagues. And it's really important that we have the right ways to fund those scientists. We know that, relatively speaking, dollar for dollar, raising funds to build an institute and millions of dollars is actually, sometimes it's relatively easy. But what can be really difficult sometimes is actually then to have the ongoing funds to support the research community. So for a long time, it's been an emphasis and a determination of the MBCF to really focus on funding people. And that's absolutely critical. And you heard from Lisa about the need to get people together in the pub. The buildings now, the research buildings, are designed to get people collaborating and talking to each other, which is fantastic. But at the end of the day, getting researchers funded is increasingly difficult. It's very, very challenging. It's a frustration that often funding is for relatively short periods of 3 or 4 years. Researchers, unfortunately, spend too much of their time having to write grant applications when we really want them in the lab or in the clinic. So we're very focused on people. We have a grant program that we are extremely proud of. We've been running it for many years. It's very, very successful. Of the 200 grant applications per year that we receive, we'll fund about 30. And they're absolutely outstanding quality applications and projects that we're doing across Australia. In the last few months, we've announced a few new initiatives which I think are going to be really important. So one of those is to try to identify up-and-coming researchers who are really the shining stars of the future. We want to create a stable long-term investment in leadership in research. So we're looking at funding for up to 10 years for those people who are really the people that are going to be on podiums like this for the next 20 plus years at least. And this will help to create a really stable funding base for a small number of really outstanding Australian researchers. We announced those late last year, and we hope to have the first two what we're calling endowed chairs. We hope to have those in place during the course of this financial year, which is really exciting. Another area that we're looking at is collaborative funding. So we want to use our dollars very cleverly. We don't have as many dollars as we would like, so we have to be really smart in the way that we use them. So we've also developed a partnership with Movember. Many of you know that Movember have an interest in prostate cancer. We're interested in how the cancers talk to each other, what are the drug relationships, what are the protein genomic relationships, whatever it is that we need to learn. But we're increasingly aware that there are great opportunities to learn more about cancer by being very open to the relationships between different types of cancers. So we have a $2.5 million fund that we will award this year to one or two major projects that straddle not just necessarily breast and prostate, but also ovarian as well. So that's a really fantastic opportunity to get collaborative grants and getting researchers, perhaps from multiple institutions, working together to really make a difference. We're also looking at some international fellowships, so sending young clinicians and researchers for perhaps a year overseas to work in a lab to learn new technologies, new approaches to care and to research, and to bring those ideas back to Australia in a year's time. And the other new initiative this year is a commissioned piece of research that we want to do, which will take us to understanding better why some people do better than others. So you'll be aware that we have a mission which is towards 0 deaths by 2030. That's a hugely audacious goal, we know that, but we look back to the experience and the change over the last 20 years or so that Alex referred to in his talk as to how much we've moved forward, and that the survival rates have drastically improved, and there's still a way to go. So we're commissioning a piece of research here in Australia to look at the how, the why, the when, the wherefore of survival in Australia, and particularly to understand the pockets of breast cancer where people don't survive, so that we can understand those and target research around those areas. So again, all very focused on people in terms of research, but ultimately towards our goal of 0 deaths by 2030.
Thank you. So maybe taking it back to the biology and the clinic, we've had a lot of questions about a type of breast cancer that we haven't really spoken about today, which is ductal carcinoma in situ. Would someone on the panel like to comment about, you know, what is it and what's the latest thinking around how DCIS or ductal carcinoma in situ needs to be managed?
So ductal carcinoma in situ is essentially, it's a precancer. So I think one of it's a bit of a misnomer, right? Because it isn't actually carcinoma. I think it's important for women to realize that if they have DCIS, it needs to be managed because it can become an invasive cancer, but it itself is not a cancer. It's essentially a precancer. But because of the risk of it becoming an invasive cancer, a proper cancer, it's typically treated with surgery, sometimes radiation, sometimes anti-estrogens.
And then I guess at the other end of the spectrum, we've had a lot of questions, a lot of interest in metastatic disease, which is good because we've spoken a lot about that today, but a number of people with a particular interest in brain metastasis, and I guess trying to understand what the latest is in brain metastatic research and in treatment.
So, it's a very challenging area because these patients tend to be excluded from clinical trials in the past. New therapies, what we call systemic therapies that get into the blood and circulate everywhere in the body, have now been designed that specifically also act on the brain. And it's still early days at the moment, but there are some promising new therapies for patients with brain metastases. But typically, brain metastases are managed, if possible, through surgery or radiotherapy to begin with. But whilst those things are happening, clearly we need systemic therapy because patients with brain metastases often also have spots elsewhere in the body that need treatment, and the most effective treatment is something that gets to everywhere rather than just the brain.
And I guess following on the theme of metastatic disease, there's a lot of interest in lymph node metastases in the questions that we received from the audience. So I guess trying to understand a little bit about what it means when your tumor has gone to your lymph node. Is that a metastasis? What does that mean for your prognosis and your treatment?
So the sort of basic prognostic factors that have stood the test of time, that have stood the test of technology, that still outperforms a lot of these technological advances that we've seen today, is the tumor size and the number of lymph nodes. So at the end of the day, those things still predict for outcomes. So we always, when you see your surgeons, when you see your medical oncologists, we're always interested in the size and the number of lymph nodes. Here at the Garvan, we are doing some research focusing on the lymph nodes because often it's taken out and it's quantified. You know, there's 3 out of 14 lymph nodes involved, but you know, that's about it. Lymph nodes are routinely collected on all patients, and as part of our Project Share, where we ask our patients to partner with us in our research, we're now asking whether we can actually use some of those lymph node samples to bring back to our lab. What we're studying together with Alex would be things like the immune cells in the lymph nodes. We're trying to see if the lymph nodes secrete a certain antibody to early exposure to the breast cancer, because the lymph node, if we use a baseball analogy, is the first base. So it goes from the breast cancer into the lymph nodes and then typically to the other parts of the body. It doesn't always follow that rule, but most of the time it does. So the lymph node gives us an opportunity also to do patient-centered research using patient samples to try to understand this process of how those cells get to the lymph nodes, how the immune system, the first port of call, is activated at the very early stages.
And just to be clear, the lymph nodes that Elgine's referring to are the local lymph nodes. So here, here, and under the armpit. Not lymph nodes in the abdomen, for example, which is part of distant metastasis.
So we've got a really interesting question here about extreme responders, which is something that in research is becoming an interesting area of research, and perhaps some of you might like to comment on that, on the relevance of studying extreme responders in a clinical setting.
So extreme or exceptional responders are, are exactly what it sounds like. So if you have a patient in whom you give a drug and that patient has eradication of the cancer and is doing really well years later, that's considered an exceptional response. That's not the norm for metastatic disease, for example. So there was that clinical trial I mentioned where we did the EGFR inhibitor, to triple negative breast cancer. So we had a handful of patients, where the cancer didn't find the back door, it didn't find the window. The drug worked, and in fact, so that trial finished in 2008-ish, and there was a patient who was on therapy until last month, right? So doing great for many, many years. So that's an exceptional response. So the question is, how do you identify those patients, right? And sometimes it's in the setting of a trial where the drug is considered a failure, right? So say you have a trial and you have 100 patients and only one responds to the drug. The drug trial is considered negative. It's a failure, and typically it moves on. But occasionally you'll have that one patient who does great with that drug. That's really important to understand why that is, because that's where personalized medicine comes from, right? For that patient, that drug was perfect. And knowing why, I think, is actually really, really important.
Alan Spiegelman, I don't want to put you on the spot, but is there something that family genetics tells us about exceptional responders in these kind of patients?
Very good question, and I don't have an answer to that really. Broadly, we see people with a range of mutations within the BRCA genes and some of the other genes that we're now testing for as well on a panel basis. I'm not aware that the literature shows any particular, what we call a phenotype-genotype correlation as yet, so I don't have an answer for you.
Okay, I think we're out of time for the panel. I'm sure we could have this conversation for a lot longer, but please join me in thanking all our panelists, Lisa Carey, Tennille Fankhauser, Alan Spiegelman, Elgene Lim, Lee Hunt, and Sarah Hosking. Now we're almost ready for a cup of tea. That's right, but first we're going to hear from Terry Little from the Estee Lauder companies, who are the sponsors of this event and for which we're very thankful, and he's going to close this event.
Well, thanks, Alex, and I think thank you again. I could have sat there all morning listening to these, and I'm sure there are a lot more questions I won't answer, but a big thank you to everybody on the panel again. Thank you. Thank you, everybody, for attending today. I'm here because 25 years ago, Evelyn Lauder launched the Breast Cancer Awareness Campaign and created the Pink Ribbon to give a voice to a disease that was impacting women at a very alarming rate. Her goal was to bring women, men and families in every corner of the globe to enhance awareness, raise funds and inspire action in the fight against breast cancer. The result has been a global campaign now active in over 70 countries, has raised over $65 million for education and medical research. Over the past 20 years, the Breast Cancer Awareness Campaign in Australia, driven by our dedicated employees, they are the people that raise the money. It's not the company has money, but the people actually who work for us raise the money. And we have had a number of our employees have been stricken by breast cancer as well, so it's very dear to our hearts. And we've funded research scholarships. We've put out literature to improvement of telling people how to deal with it. Distributed pink ribbons, I think everybody's seen the pink ribbons. Consumer brochures and developed support materials for those diagnosed with breast cancer. We're very proud to continue those partnerships in our commitment to breast cancer education and medical research through sponsorship of this symposium and the community of breast cancer update. In addition to this, I'm pleased to announce that as well as today, that the Breast Cancer Awareness Campaign will donate a further $25,000 to support here at Garvan. Thank you. Our partnership with Garvan and their breast cancer research team started only 2 years ago. And I think we brought a lot of our employees here and got a fantastic tour of the facilities here and seeing firsthand what work was being done here. So we look forward to continuing this for many years to come. So thank you. I'm sure everybody's dying for a cup of tea now. So if you'd like to go outside, there's tea there. So thank you very much.